Hi there, this is Jacob Nash Algebra Lessons. This is Unit 3, Lesson 8, on the quadratic formula. So far in our lessons, we've learned how to factor. And what was the result of factoring? Well, when you factor, you basically just do it's kind of like you're just simplifying it, but not like in terms of having a square. So you kind of just make it to where it has no square in it. And so, but if there's an equal sign, remember if we set it equal to 0, that's how we found our zeros for the equation. Remember x-intercepts. That helps us to graph our quadratic that you're going to learn in the next lessons. Quadratic formula is just another way to find those, and you may have learned that as well as factoring in Algebra 1, but it's retaught just because it's a complex formula. And you'll also learn that there's also completing the square that's in Lesson 10 that we'll learn. So the quadratic formula, what it is just a formula that you use to plug in numbers so that you can find your zeros. So here's what it is. You may have learned it. So it's x. X represents your zeros. Because remember, zeros are just the x-intercepts. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and then that whole thing is divided by 2a. So you might be wondering what a, b, and c are, or you might already know, but they're just parts of the equation that you're given that you'll use to plug in for those numbers. So this formula might not be very easy to remember, but it's useful if you can remember it. And there was something, I definitely remember it. It's one of the things I remember the most because I had a teacher that played it like 50 times in like an hour, and it's terrible, but at least I remember it. So, let's look at an example of how you would use this. So let's say we had 2x squared plus 8x plus 9. Okay, well, first of all, we need to say, let's just make that a negative, because I'll tell you why in a minute. But the reason why you would use this instead of factoring is that factoring doesn't always work, as you know. Like if you had, well, basically just this equation. You can't factor this, because if you try to, well, you know that we would multiply this and then you would get negative 18, but nothing that multiplies to get to negative 18 can add to equal 8. So that's why the quadratic formula always works. But it still is useful to know to factor, but I like using this the most, but it sometimes takes a little bit longer. So, what is A, B, and C? So, let's do our A's in blue. So, we have A here and here. A is negative 2. Then we have 8. That's our B. Then C is 9. And you only have to plug that in once. So, no, that's not highlighter. Okay, so we'll learn in the next lesson about something called discriminant. Discriminant is something that I just circled in green without the square root on it. Just b squared minus 4ac. And if that number is negative, then remember that would mean you'd have to take the square root of a negative, like 1. And remember in the last lesson we learned that's not something you can do. That makes it imaginary. So that's the reason why I made the 2 negative, because I can already tell with the numbers that I chose, it would make it imaginary in this case, and I don't want to do that just for this purpose. So let's plug in our numbers. So negative something plus or minus the square root of something squared minus 4 times something else. And that's all divided by 2a. Or let's see what it is. So b, that's 8. So negative 8 plus or minus the square root of 8 squared minus 4 times negative 2, which is a, times 9, which is c, divided by 2 times negative 2, which is going to be negative 4. So let's simplify this to see what we have. We have negative 8 plus or minus, and if you might be confused about this plus or minus, why is it plus or minus? Because remember, usually quadratics have two x-intercepts because of the shape that they are, a parabola. So that plus or minus means that we'll end up with two equations. It's kind of like when we did the absolute value, but it's not connected really, but it's kind of like that. Sometimes we'll learn about this more in the next lesson, but sometimes it might only connect to it once. That would be if one of these turned out to be imaginary. And also sometimes there's no solution when they're both the plus or minus turns out to be something that's imaginary. That means that it never touches the x-axis, so there are no zeros if it was like that. So we'll talk about that more. So 8 plus or minus, so 8 squared is 64, and then 64 minus 2 times 4, well, they're both negative, so that would be 64 plus 72, that's what negative 4 times negative 2 times 9 is. So plus 72. That's why I made this a negative, because if it was a positive, then it would make it 64 minus 72, which 64 minus 72 is negative 8, which would make it imaginary. So we have the square root of 64 plus 72, which is 136. So that's not a perfect square. So that's not so good. But that's just how it is, because I couldn't think of exact numbers that would be like that. So whenever, okay, why did this just scroll? I don't like that, okay. There, if I use 2 fingers, it does that. Okay, so whenever there's, the number that's here is not a perfect square, then you can just stop right here. Except we might want to just change this. They're both negative, so we can just change it to this. So that would be our answer if that's not a perfect square. But if it was, let's just change this 136 to, let's just take away the 1 and just say it was 36. Well, that is a perfect square, because the square root of 36 is 6, because 6 squared is 36. 6 times 6. And so now we have 8 plus or minus 6 divided by negative 4, or negative 8 on top of that. So negative 8 plus 6 divided by negative 4 is 1/2. And then negative 8 minus 6 divided by negative 4 is fraction 7/2, which is, it's really 3.5. So those are our 2 zeros if that happened to be, if this happened to be 36, but it was 136, so it would actually be different than that. But that's how you use the quadratic formula. All you have to do is plug in for A, B, and C, and then solve all the way till you get actual numbers. If the number in the square root can be square rooted evenly. If not, just leave it how it is, and that's how you do it. So thanks for watching, and that'll be it.